Probability in Venn diagrams. So a Venn diagram is a rectangular shape and it has circular shapes that represent the events. Let's assume we have two events of learners doing mathematics and learners doing physical science. So the circle that is represented by M, it will represent the learners that are doing mathematics, and the circle that is represented by P will be the learners that are doing physical science. But now, if you look at the space outside here, it will represent the learners that don't do maths and physical science. So if a learner is not doing maths or physical science, we are going to put them out here. So now a Venn diagram, it represents the event and also the people that are not participating on the event. So there's also something that you need to understand, which is the sample space. So the sample space will represent the total number of learners inside the Venn diagram. So let's say, for example, we have the following Venn diagram to say number of students that are doing maths is 10 students and 5 students that are doing physics, and then now 3 students don't do maths or physics. So what will be the sample space of this Venn diagram? So the sample space will be the total number of students. So the total number of students is going to be 10 plus 5 plus 3, which is 18 students. So that is the sample space. So when we talk about probability of Venn diagrams, we need to understand what is called the general equation for probability. So the general equation for probability is probability of A or B equal probability of A plus probability of B minus probability of A and B. So but first we need to understand what does probability of A or B mean and what does probability of A and B mean. Let's say, for example, we have these two Venn diagrams whereby we have students that are doing maths and physical science. And then the other Venn diagram is that we have students that are doing maths and students that are doing physical science, but we also have students that are doing both maths and physical science. So this will mean that if we want the probability of A and B, we are going to look at the students that are taking A and B at the same time. So in this case, this part of intersection here, it will represent the probability of what? Of the students taking both maths and physical science. So this is AND. But now, when we talk about OR, so if we say now, students that are taking maths or physical science. So we are talking about all students that are taking maths or physical science. So this doesn't matter if the students are taking both maths and physical science, or the student is taking maths only, or the student is taking physical science only. When we say maths or physical science, we're talking about all students that are taking maths or physical science. So in this case, the students that are taking maths or physical science in the diagram is going to be this whole circle of maths and then this whole circle of physical science. But on this part here, the students that are taking maths and physical science, maths or physical science is going to be this part here, and this part here. So that means everything inside this part here, it will represent the students that are taking maths or physical science. So that is the difference between or and and. So and means intersection, or means what? Including everything. So let us try to discuss this much further. To say that if the events don't have intersection, we are going to call these events mutually exclusive events. So these are exclusive. They don't have intersection. But now if the events have intersection, which is and here, we're going to say these are inclusive events because they have intersection. So this will mean that in here on the exclusive events, the probability of A and B, it is going to be 0 because we don't have learners that are doing both maths and physical science. And therefore, the general equation of probability of A or B, it will reduce to be probability of A or B equal probability of A plus probability of B because we don't have an intersection. But now if we have an intersection, that means the general equation will be that. So if we continue to talk about something that is called exhaustive events. So when we talk about exhaustive events, we talk about events whereby we don't have students that are outside. So this means now all students in whatever grade, they are participating in maths or physical science. So if we don't have any outsider, therefore the events will be exhaustive. So exhaustive events, that means what? Everyone is participating. Everyone takes place in either maths or physical science. That is when we have exhaustive events. So if we have exhaustive events, this will mean that the probability of A or B, it is going to be 100% because now everyone is participating. We don't have anyone that is not participating in maths or physical science. So for exhaustive events, whereby we don't have an outsider, the probability of A or B is going to be 100%, and then 100% is represented by 1. So the probability of A or B for exhaustive events is going to be 1. So we also have to discuss what we call complementary events. So when we talk about complementary events, so complementary events are events that are mutually exclusive and exhaustive. So if the events are mutually exclusive and also exhaustive, the events will be complementary. We know that if the events are mutually exclusive, the probability of A or B is given as probability of A plus probability of B because we don't have the intersection. But now, if the events are exhaustive, that means we don't have anyone that is not participating. This will mean that the probability of A plus probability of B is equals to 1 because the probability of A or B is the same thing as probability of A plus B. So we'll come to a point whereby if we want probability of A in exhaustive events, the probability of A is going to be 1 minus probability of B. But now we can also represent the probability of B by saying probability of B is the same thing as probability of not A. So this means that if we have a probability of not A, for us to get the probability of A, we are going to say if the events are complementary. Therefore, 1 minus probability of not A, it is going to give us the probability of A. Or if we have the probability of B, for us to get the probability of A, we're going to say 1 minus probability of B. But this only happens when the events are complementary. Complementary means mutually exclusive and exhaustive. This is all for the video. Thank you.